new problems, new perspectives. Okay, so fiber spinning process currently produces a fiber whose strength is normally distributed, and the mean is 75. That's newtons meters squared. You don't really need to know what that means. We just know that the mean is 75. And, well, this is saying the minimal acceptable strength is 65 newtons per meter squared. So if our value is less than 65, then it's below acceptable, less than acceptable. Okay, but there's actually no question here, just some information. So let's move on to look at the question. Okay, 10% of the fiber produced by the current method fails to meet the minimum perspective. So what is the standard deviation? Okay, so let's make sure we understand what information they are giving us. So they're giving us that the probability that it doesn't meet spec. So in other words, the probability that we have less than 65 is 10% or 0.1. Okay, so this is what they're telling us. Okay, so what we're going to do is we're going to look for the z that gives us a z-score of 0.1. Okay, then we'll know how many standard deviations we are working with here. Okay, so let's find out. Let's find out when we have a z-score of 0.1. So I'm going to want to change this to be 0.1. I'm going to drag this down until I get close to 0. Okay, there, I'm really close right there. Okay, negative 1.27. So in order to have only 1% meeting spec, my z is going to equal negative 1.27. Okay, so we have some information about what our z-score is going to be. What is the standard deviation of the current process? So they didn't tell us the standard deviation. They did tell us the mean, and we figured out what z is going to have to be for 10% of these things being below 65. So we're going to, again, use this formula and plug in what we know. What we don't know is standard deviation, because that's what it's asking us for, but we know everything else. So when we have a z-score of negative 27 is when we have a value of 65 minus the mean, which is 75, over sigma. And we'll just solve for sigma. Okay, so doing a little bit of algebra here. I'm going to skip a little bit of steps here. Okay, negative 1.27. And you can pop that in a calculator. Let's take a look at negative 10 divided by negative 0.27. Okay, and we have, let's call it 7.9. So the standard deviation right now for the process that we have, based on the information given, is 7.9. Okay, moving on. Same problem, part B. Okay, but okay, the mean is staying the same. The mean remains 75 newtons per meter squared. But they're saying, what must the standard deviation be so that only 1% of the fiber fails to meet specification? Okay, so that means that, remember, failing spec is when x is less than 65. Okay, that means failing spec. And we want that to be only 1%. So in other words, we want that to be just 0.01. Okay, so I'm going to go back to my z-score again, and this time I'm looking for what z-score is going to give me 1%. Okay, let's go back to my z-score. And I might have to change my scale a little bit here, so I'm going to go down to -3. And let's change this. Okay, I'm going to go into, I'm looking for the value of 0.1 here, 0.01, sorry. If you're on your table, if you're using your table, you're looking through that table to find when this equals 0.1 or is very close to it. And, okay. Now you could go either a little bit above or a little bit below, but because the question is asking for being 1%, I probably want it less than 1%. It really doesn't matter, actually. These are both extremely close to 1%. So either of these z-score values or z values would work. Let's take this one, -2.32. So that gives me about 1%. So we want a z that is equal to -2.32. And what must the standard deviation be? So we can change the standard deviation again. We're going to use the same formula from before. We know what our z is going to be. Our z is going to be -3.2 now. That part has changed. This part actually hasn't changed here. It's still 65 minus our mean. But our sigma is going to change now. Okay, a little bit of algebra. We get -10 for -2.32. And let's just need to change this value in here. 2.3. Okay, there you go. Let's call it 4.3. So our standard deviation needs to change to be about 4.3. Oh, whoops. And that will give us only 1% of our spec failing. Okay, now they're giving us the standard deviation. Okay, so before we were getting asked for it, now we're being given the standard deviation is 5. And we're being asked to find the value that the mean must be to get, so that we get 1% of the fiber. Okay, from before we can use this, the same thing from before. We know what the z-score for 1% is, so the probability that x doesn't meet the spec is still going to be 0.01, so we can reuse what we found before, and that is z would have to be -2.32 approximately. And now back to our formula. What's changed now is that we don't know what the mean is. So the mean is going to be our variable, but we do have a standard deviation. So z is this. Our minimum spec is still this, but mean is going to change, and standard deviation is 5. Okay, again, I'm using the same. I didn't write it out here, but you should have seen this equation over and over again. So that's z x minus mu over sigma. So again, a little bit of algebra here. We get, let's say, negative. I'm just going to round off here. And if we bring mu over here, 65 plus 11.5. Okay, so our new mean would have to be 76.5 approximately. And there you go. Okay, so notice there's a pattern here. We're getting different values to solve for, but we're using this equation over and over again. And the key thing is they're giving us different percents, and they're giving us different means and different standard deviations, but they're always not giving us one and giving us the rest. So it's a matter of finding which values we know in order to solve the ones we